Let's discuss question number 29 from test 2, and this is from deflection of beams, so strength of materials. So a cantilever of length L carries a concentrated load W at its midspan. So let me just draw the figure. So you have a load W at the middle of the span, so L by 2 and L by 2 on both sides, and you have a prop cantilever. That means you have an extra reaction at the end supported on a rigid prop. So we need to find out this reaction at this prop. Okay, now before this, let's revise the formulas. Okay, let's revise the formulas. Okay, so for a cantilever beam, there are two things which you need to remember. Okay, one is when you apply a load, let's say somewhere in between, say this is L1 and this is L2. Okay, so okay, let's take a very simple case. Instead of this complicated case, let's take a simple case, because then we'll come back to our original problem. If you have a cantilever and you have a load at the end, and this is the load, so now this bends like this. Okay, so at this point there are two things which you need to know. One is the deflection formula, and the other is your slope. Like at this point, how much, if I draw a tangent at the end, how much angle does it make with the x-axis. So there are two formulas, and the formulas for this comes from your m is equal to minus ei d square y by dx square. So this is basically deflection of beams governing equation. So from this we'll get the formula. So delta is your pl cube by 3ei. So this again comes from this double integration. So this is the maximum deflection when you have the cantilever at the end, and the slope is basically wl square by 2ei. So these are the formulas which you have to remember in order to solve any other case, which is just so this will use these two, the deflection and the slope formula. Now in this case, in our case, we have a prop cantilever, and now this problem I can just superimpose as only cantilever applied at W, L by 2, L by 2 plus, so this is free, this is basically free, so this will basically bend in this way, right? You have bend till here, and then it will follow straight, right? Okay, now here I just consider this problem as a superimposition of this and this reaction load R. Or so as to say, let's load this. Okay, let's take this problem. Okay, now this I can just superimpose as one. You have only a straight thing, W is applied, so it basically bends in this way, and then the straight. Okay, remember that here the deflection has to be 0. So this, now you have a reaction. Basically here you have, if you look at the loading, you have W here and there's a reaction at the prop. Okay, so at this point the deflection is 0. What I'm doing is I'm just considering this problem as a combination of two problems where I don't have this R, so it will behave, the bending behavior would be this. Now if I have only R, say there's no W, only R, so it will just bend in this way, right, because of R. Okay, now if this deflection due to the load R is equal to the deflection due to W at the end, deflection due to load W is equal to deflection due to R, then the net deflection at the end is basically delta W minus delta R, and it will be 0, and that is the case which happens at the prop. Okay, so now we need to individually find out the deflection at the end due to load W and deflection at the end due to R, and we need to just equate. So how do you find out deflection at W? Now deflection due to the load, under the load, is basically given by this formula. Okay, So I know this deflection at the midpoint, and I need to find out deflection of the load. Now after the load, there will be another thing which we can see from this equation. You can see that this will be a straight line, okay, and there will be a slope here. So let's find out delta W. Let's calculate first delta W. So you have bending like this, and then it's a straight line. So at this point I have delta M, the slope as theta. Okay, there's no load after that, so it'll be a straight line. Okay, this slope. So delta W will be delta M plus this slope. So this is basically, I mean, the slopes are very small, so tan theta and thetas are also same. So tan theta into this length would basically give me this part of the problem. So tan theta into this is again L by 2. So tan theta into L by 2 will be basically this part, and this part anyhow is delta M. So this combinedly will be delta W. So delta M is deflection under the load. We can just directly use this. So W into the length of the beam from the built-in the load is L by 2. So L by 2 whole cube by 3EI. So I'm basically using this, plus tan theta is theta because slopes are really small, and that is W L square by 2EI. Now length, which part of the length? It is L by 2 here. So W L by 2 whole square by 2EI into L by 2. So this becomes basically W L by 2 whole cube if I take common, and EI if I take common, this will be 1 by 3 plus 1 by 2. Okay, so this is due to W. Now due to R, it's just the point load at the end, so I can just directly use this formula. So it will be R L cube total length, because the built-in and the load application are separated by distance R. Okay, so these two has to be equal. So delta W is delta R, WL by 2 whole cube by EI, and this is 3 plus 2 5 by 3 2 6 RL cube by 3EI. So from this I have R being 5W by 16. Just cancelling L cube and stuff like that, I'll have 8 in the denominator, and this 3 will cancel 6 2 times, so 2 into 8 will be 16, numerator will be 5. So this is how I find out. So this is basically a problem on deflection of beams, and if you have these rigid, I mean, because you can't, this is a class of statically indeterminate problem, that is you can't just determine from statics, because this will have three unknowns, two unknowns at here, unknown reaction, unknown movement, and this is also unknown. So three unknowns, and static equilibrium equation you can write vertically as well as movement. So two equations only you can write, and three unknowns. So you can't find out only using statics. So you need to basically use this deflection of beam equation. So this is pretty standard, 5W by 16, and therefore the answer is C. Option is C. Thank you.